Hey everyone, and welcome back to the second video of this math course. In this video we'll officially begin with the topics that we have to cover, the topics that I told you that we're going to cover in this course. So the first topic that I told you that we're going to cover is that of the complex numbers. We're going to start off slow. We're going to start off with a little bit of background on numbers. After we're done with that, after we're done with what type of numbers we have, that is the natural numbers, real numbers, and other numbers that you might have already seen in grade 9th and 10th or before that. After we're done with that, we're going to start by a little bit of concept building on for complex numbers. Then we're going to go to the rationale behind complex numbers, that is why do we even have complex numbers and why do we need complex numbers, and what to do, where do we actually need complex numbers, where do complex numbers exist, and where do complex numbers come in handy. So let's begin this short video on complex numbers. So the first thing I would like you to recall is the main concept of numbers. On this slide, as you can see, there are many numbers shown over here. Some are the subsets of some other numbers. If you see over here, we can see that these are pretty much every number that you might have seen before in any of your math curriculums. We start with the innermost circle over here. This, as you can see, is the natural numbers. These are the natural numbers. Natural numbers are basically all those numbers that we use for counting, that are used naturally, as you can see from the name. So there's no zero in that. We usually count from 1 and 2 and 3, and that is how counting is done everywhere. After natural numbers, as you can see, there's the whole numbers. The reason why natural numbers are basically a subset of whole numbers is because whole numbers have zero. So they have one extra number, so natural numbers become kind of a subset that, you have 0 as the whole number and 1, 2, 3, then the natural numbers come after that. Both of these are actually the subset of integers. Integers, the difference between integers and natural numbers is that integers are also include negative numbers. So you have -1, -2, -3, then you also have 0, 1, 2, 3. So you can see that it is a combination of whole numbers and natural numbers and also negative numbers. So that's where you can get integers. Integers are basically used everywhere in math. These, by the way, all of these are basically called real numbers, and this diagram over here shows how real numbers are arranged together, how real numbers are related to each other. After integers are done, you can see rational numbers. Now rational and irrational number, these are pretty basic and pretty straightforward concepts. Basically any number that you can find a ratio of, any number that you can express in a quotient form, that is a or b, that can be called a rational number. Even if the name of the number shows that it has a ratio NAL numbers. So 3 is a rational number because it can be expressed as 3 by 1. 10 is a rational number because it can be expressed by 10 by 2. Now the surprising fact about this is that the most famous numbers in math are actually irrational numbers. As you can see in the diagram over here, pi is actually an irrational number because we don't know the exact value of pi, and since we don't know the exact value of pi, we can't express it in the form of a ratio. We can't say that 22 by 7 is basically pi, so we have already expressed it in the form of ratio. But the thing is, we have expressed just the ratio, not the exact number. We need the exact number for it to be called a rational number. We can express 0.5 as a rational number because it can be expressed as 1 by 2. So this is pretty much the whole gist of the real numbers that we have. Now I want you to forget all of this over here because this is just the background. Rational, irrational, the main thing we have to concentrate over here are the real numbers. So the real numbers are these type of numbers are called the real numbers. Another thing that I would like to give a brief recap is perfect squares. Now anything that is inside radical, and this by the way is called radical. So anything that is inside the radical can be expressed as a perfect square. Anything that is underneath an under root will be called a perfect square if it has two real numbers, if it has two whole numbers that can give you an answer. For example, under root 25 over here, this will be a perfect square because it will give you 5 under 5. 5 multiplied by 5 will give you 25. And the same goes for under root 16. Under root 16 will be 4 into 4, and under root 9 will be 3 into 3. So these are perfect squares. Now I am only considering the perfect square so that we can first get the concept of complex numbers, and then after understanding the concept of complex numbers, then we move on to the more complex under roots. We can also try under root 24 or under root 26, under root 15 or under root 17. All of those I think you must have solved already, and you can be solved, but these over here are just so that you can understand it. But have you ever imagined, what if there's a negative inside a radical? What if rather than under root 9, that is under root of negative 9? What then? How would you solve that? Now you see, under root 9 can be written as 3 into 3, and that is perfectly solvable, and that is perfectly correct. So 3 into 3 would be 3 square, and if you put that underneath, inside an under root, that will become 3. And under root 16 could be written as 4 into 4. If you put that inside an under root, that would be 4 square, and you can get an answer of 4. But what about under root 9? If you write it as a negative 3 multiplied with negative 3, you're going to get a positive answer. You're going to get a negative 3 whole square, which is going to be 9. Just like that, under root 25. You can't write that as negative 5 into negative 5, or you can't think that, okay, I'll write that as negative 5 multiplied by 5 and negative on the outside. You can't do that, because that is not how you see this under root is arranged. It is asking you for the under root of negative 25, not the under root of 25 which has a negative value. It is asking for you for an under root of negative 25. What do you do in this case? How do you solve this question? So this is where complex numbers come into play. So complex numbers, as I say, is the second set of numbers that we have other than the real numbers. So till now you can say that I know that math is divided into two types of numbers. One is the complex numbers and one is the real numbers. Now one thing I need you to understand is that negative under root could be solved with the help of a complex number. If you see over here, this is what I was asking you, negative of under root of negative 1. I is the imaginary unit. Now you have to understand that real number is 3, 4, 5. A complex number has an imaginary value. Now imaginary, as the word is, it starts with an I. So what the mathematicians did was come up with this unit called the imaginary unit, as you can see in the second bullet or in the second sub bullet over here, and that imaginary unit is denoted by I. So I, the value of I is basically under root of negative 1. Now if you see this equation over here in the sub bullet 4 is this equation over here, this would be I is equal to under root of negative 1. So if you remove this under root over here, you get an I square, and you get an I square over here, so that is equal to negative 1. So we know this identity. Remember this identity, I square is equal to negative 1. This is the most important thing that you need to understand about complex numbers. So whenever there is an under root, negative under root, we solve it by the help of a complex number. And what is a complex number? Complex number is any number that has an imaginary part in it. Complex number is any number that has an I in it. So the under root of negative 1 is equals to I. So I square is equals to negative 1. You don't really have to remember this one. You try to this is just so that you can understand this. Remember that I square is equal to negative 1. The reason why I am telling you this is because whenever there is, let's just say, negative 25, we can break it down into a negative part and the real part. That is, basically it is still a negative 25 will also still be called in itself a real part, but I'm trying to tell you in respect to complex numbers. So negative 25 can be written as negative 1 into 25. Now when that is done, then you can write it as I square multiplied by 5 square, and then you can break it down and you can find the complex number. You can find the solution to the answer. You can write I square negative 1 square as I square, and that will give you I, and 25 will give you 5. Of course, I'll show you in the couple of slides how we are going to do that. This was just to give you a brief intro that a complex number is any number that has an imaginary part in it, and the real number is any number that does not have an imaginary part in it. Now we're going to go over the different properties of these complex numbers, how, if, what if that is just an imaginary number, will we call it a complex number, will we call it an imaginary number? Just remember that I is an imaginary unit that is used in complex numbers, and I square is equal to negative 1. Till now all you have to realize is I square is equal to negative 1. Once we are done with that, I want you to understand this. This is how we're going to find solutions to all of the negative numbers. Now let's just say there's this answer over here like this. There's this question over here like this, negative of a. Now a could be anything. A could be any number, right? It could be 25, which is the perfect square. It could be 24. It could be 39. It could be any number. So what the process of finding a complex number, the process of finding a solution to this is like this. You write down -1, you expand it, you take out the negative of a. So you take out -1 into a, you break it down, then you break down this radical. Of course this all can be written down as this, so that will be negative under root of -1 into under root of a, and then you can write it down as I under root of a, as we already saw in this slide over here that under root of -1 is equals to I. So all we are doing over here is that we are just breaking it down and then writing it down as I. Once you're done with that, then you have, of course, you can write this as I, this will remain to be under root of a, and you have your answer over here. The answer will include, if a is a perfect square, let's just say if a is 16, it will be 4i. So remember this, that whenever you have the process of solving this type of question is that whenever you have an under root of -a, of under root of any negative number, the first thing that you need to do, the first thing that you have to do is that you separate the negative sign from it. You find out -1 into a. Once you're done with that, then you deal with the negative part first. Once you're done with the negative part first, you know that it is an imaginary number. Just by looking at what's underneath the radical, you will know that this is a complex number and it has an imaginary unit in it. So I hope this is pretty clear over here. Now as for the questions, as for the practice of this, now what are you going to write over here? Now what are we supposed to write over here? Under root of -25. How are we going to solve this? So the first step, like I told you, is that you take out the radical. Once you take out the radical, then you can solve for the negative. What I meant by take out was actually that you take apart the radical. So if you want to write it down, you can write it down as under root of -1, which is being multiplied by under root of 25, which can be written down as, because now we know from the previous slide, the negative of under root of -1 would be written as I. So this is I. Then we have the under root of 25. Now it's really solvable. Now it is just like any other radical that you saw before. So this would be written down as 5i. This is the answer to this question. 5i is the answer to this question. Let me just write it down in italics so that we know that this is something different. Just like that, the first thing that we have to do. So I want you to come up with the answers of this. The first thing that we have to do is that we break down the radical. We know it is a negative sign inside it. So since it has a negative sign inside it, what we're going to do is we're going to break it down. We're going to find out the complex part, and we can find out the real part, and then we write it down as a complex number. Sorry, we're going to find out the imaginary part. So we write it down. Negative under root -1. Then we write down the next radical, which is -9. And then we break it down. We have I over here for the first answer, that is under root of -1. We will multiply that by the radical, that is under root 9, the negative radical, and then we would get 3i as our answer, because this is what the answer is, because this is the solution to this question. Then let's go beyond that now. Under root of -16. What is under root of -16? We break it down. We break it down into under root of -1 multiplied by under root of 16. That will give us I being multiplied by the radical 16. Now we all know the answer to this one. I would be I, under root 16 would be 4, and that is how you have your answer to this question. So this is pretty much it for complex numbers. This is the main reason why complex numbers even exist. This is the reason why, this is how we solve complex numbers. Negative and radical, it's a complex number. What we have to do, we have to find the imaginary part. How do we do it? We take apart the negative radical, we write it as -1, and we write it as the real part separated from that. And once you're done with that, we can find the solution to the answer that will have an imaginary part in it, that is I. So this is pretty much it for the introduction of complex numbers. We will continue with the same concept and the same topic in the next question, in the next slide. So hopefully you all will join me then. Thank you very much.